Hi, 6th grade. This video will review Chapter 11.1, which discusses how rivers work. Remember that we are reading Chapter 11 in order to answer our essential question, which is the question that this whole unit is based around. That question, just to remind you, is how can we encourage those around us to be more responsible water users and protect others from pollution? So as we think about water resources, both in terms of the water cycle, in terms of the ocean or rivers, streams, lakes, ponds, aquifers, etc., we want to think about how can we responsibly use those water resources, as well as how can we protect them from pollution. So in order to kind of answer that question, we need to know a lot of information about how those river systems, how ponds, lakes, water cycle, etc., how all those things work. So the purpose of this whole project, and in specific reading Chapter 11, is so that we have enough information so that we can choose, understand, research, and propose a solution to a water problem. And in order to do that, we first need to understand the basis of fresh water. Chapter 11 provides much of that information, and through your reading and class conversations, we will examine the information more closely. So we're going to do just that right now. So Chapter 11.1 talks specifically about river systems. In order to understand river systems, we of course need to talk about the water cycle. The reason the water cycle is important is because without rain and without runoff, you're not going to form small rivers. We'll talk about how that works in a second. So first of all, something important to understand is erosion, which is what water does to land as it runs over any kind of dirt surface. So erosion is the general process of removing and transporting rock and soil. This can happen in little bits at a time, where it's just wearing away little tiny pieces of dirt and sand, one piece at a time. Or if there's enough water or the soil is loose enough, you could have entire mudslides or collapses of areas because you are moving that much water through dirt at a time. This occurs because water is moving. So we call that process the water cycle. This is the third time this year we've talked about the water cycle, so I'm going to make it pretty brief. We know that it's the continuous movement of water from sources to air and the ground, and then back to other sources. So it kind of goes from here to here, and then back to those same sources, right? If air and ground are kind of one general step in the process, it goes from a source to the air, potentially to the ground, and then back to other sources. Now, this is the continuous movement, and therefore, when we talk about the steps of the water cycle, there is no first step. Water right now is in the air, it's underground, it's in rivers, it's in streams, it's in ponds, lakes, and the ocean. So where that water goes from there is its first step, depending on what water we're talking about. But there is no first official step of the water cycle. The two new ones, or two relatively new ones in here, are infiltration and percolation, which is the movement of water through the ground. Infiltration is the general process, like I've called out right here. That's just water generally moving downwards through the ground because of gravity. Percolation is a specific process where that water goes through pores, meaning little tiny spaces in the soil. So you've got a general process and a specific process. Do you really need to know the difference between infiltration and percolation and how very specifically they're different? No, not at all. What we want to understand is that condensation is that water vapor, so gaseous water, goes to form into liquid water right before it rains. And then that rain is going to run off of dry surfaces, right? It's going to run off of the ground, down mountains, across streets, over roads, in pavement, anywhere across the ground. As that runoff runs across the ground, it could potentially infiltrate and percolate down into the ground and eventually fill up an aquifer. Remember, we've talked about aquifers a couple times, and an aquifer are those underground storage tanks, right? Those happen naturally. It's not that somebody put them there, but it's an underground storage tank made of stone that essentially hold big, huge amounts of clean, fresh water that we can later drink or use for irrigation. That might just be a note that you throw on the side there. If that runoff doesn't infiltrate or percolate down into those aquifers, it could potentially run off into a pond, lake, or ocean. Potentially, it will also evaporate and go right back up to this process where it's in the air as water vapor and has the potential to once again form clouds and be precipitated down towards the earth. So this is happening all over the place all the time. Water that is evaporated in the middle of the United States might not actually form into water droplets and rain until it hits the East Coast or until it's somewhere over the Atlantic Ocean and it rains over the ocean, right? So water doesn't just stay in one place, it moves all over the place, whether as runoff or whether it's in the air. So as that water is running across the ground, right, we're again, I'm going to erase all this stuff, as we're now talking specifically about runoff. As that runoff after it's fallen from the sky as some type of precipitation, rain, snow, sleet, hail, it's going to eventually run or flow across the ground. And as those tiny little streams of water, right, just really like little lines of water run across the ground, those are going to start to merge together. As they start to get bigger and bigger and bigger and bigger, they're going to start to form rivers, right? So that's how we connect this runoff idea with river systems. So a river system is just that smaller streams and rivers are all part of one big river system that eventually end up in some kind of source, right? It could end up in a lake, it could end up in the ocean. But all of those smaller, tiny little streams that build into a couple bigger rivers, and then those rivers that all merge into one source, that's called a river system. So those smaller streams, the small guys, those are called tributaries. Right? So as you get those tiny, tiny, tiny little ones that then form into little streams and little rivers, that is one tributary. 5, 10, 15, 100 of those tributaries flow together into a larger river. Right? When you're talking about all of those different streams and rivers together as one system, you're talking about a drainage basin or a watershed. So that drainage basin or watershed is essentially the all-encompassing word that accounts for the streams and rivers that flow and merge together before ending up in a lake or in the ocean. So this whole thing right here is kind of the system, right? It is what we're talking about when we're talking about all of those different streams and rivers combined will be within the watershed. The reason that these all form is because you've got some kind of hill, right? Some kind of hill or mountain that creates some kind of gradient. So if, here's looking at it from a profile, a side view, right? There's your hill, and here is your lake down at the bottom of it, right? The water is all going to flow this way, and water could be flowing from over here, and it could be flowing downwards from over this direction and come over here. And each of these is a tributary that then combines into one river. So this whole area here would be called your drainage basin or your watershed. And then it empties into your source. Or in this case, we're going to just say that that's a lake. So all of those tiny little rivers combining into one big river, then that big river draining into some kind of source is generally called your watershed. So these streams and tributaries and big rivers, they all start to wear away soil and rock. And when they do that, that's again called erosion. And that is what ends up forming a stream bed or a river bed. That is what we call a channel, right? The fact that a river or a stream all flows together in one channel is because that water over time wears away more and more and more and more dirt and rock so that it actually cuts a path through that rock. Right? If you think about the Grand Canyon and the reason why it's twisting back and forth is because that water over millions of years has run down the slow gradient and has slowly and slowly worn away at the dirt and rock to create that really deep channel. So the gradient, that is just a fancy word for slope. right? Slope is a concept that you've probably heard about in math class, right? If you're looking at XY coordinates on a graph and you say, okay, here's one point, here's another point, let's connect those, we know that that one is less steep than if we go from here to here, right? Is A or B more steep? We know that A is more steep. We know this from hiking, we know this from skiing, or we know this from math, that the steepness of something is called its slope, which is also its gradient. So essentially, the more gradient, or the more steeper gradient that a slope has, it means there's going to be more erosion, right? That water is going to move faster, it's going to carry dirt and rock away faster and can actually rip off bigger pieces of rock if that gradient is steeper. Discharge is the amount of water per unit of time. So meaning how much water is actually flowing down that river, right? Some rivers, they could be really, really steep, but they might not have much water flowing down them, right? So it could just be a trickle of water going down a really steep hill. Or you could have a ton of water going down a pretty flat river. Or you could have a ton of water going down a really steep slope. So the point is that we need to know both about the gradient as well as the discharge. So both about the slope as well as how much water. These two things determine the load. So they determine how much material, how much eroded stuff gets carried out by the stream. So that could be found on the bed of the river, that could be found suspended in the water, dissolved in the water, or carried all the way downstream into a source. So essentially, I'm just going to move this whole screen over here. We could have a really steep slope, right? Or we could have a pretty gradual slope, right? This one is obviously going to be faster. This one is going to be a little bit slower, right? If this is A and this is B, we know that this one will be slower. So that is essentially talking about the gradient. But if we're talking about water as well, we are talking about the discharge, right? This word right here. We want to know, is it 1 gallon per second, or is it, 1 million gallons per second, right? If it's 1 gallon per second flowing down this slope, that's actually still going to be pretty darn fast and a decent amount of water running down there, right? A gallon per second running down that really steep slope, that's going to have a lot of force. But a gallon per second coming down this less steep one, we're not as worried about. 1 million gallons per second, we're going to be worried about no matter what, because that's a lot of water. So whether it's coming down B or it's coming down A, we're going to be pretty worried about it. And if it's coming down A, you better get out of the way. That rhymed. And what that'll tell us is how much load, meaning how much stuff, gets carried down the mountain. So now that you've got these notes, on the next page it asks you to draw the water cycle with the hill and river system. So here's an example that I just found on the internet. It's got, you could use that as kind of a jumping off point. What I'd like you to include in yours are these 5 things. You should include the 6 steps of the water cycle, meaning these 6 steps up here, right? And again, they're called quote-unquote steps because they don't necessarily go in order. You should have a hill or a mountain, just like this, or this, or this. You should have tributaries and a river, right? So you should have smaller little tributaries that then combine into one bigger river. You should have an aquifer, meaning you should have some underground storage, meaning like down here. See how there's a little underground stream and another underground stream, and you've got this little underwater lake there. You could draw in something like that. Then you should have a lake or an ocean. Bonus if you can have both. So if you can have not only the tributaries that then combine into a river, but part of that river then drops off some of the water into a lake and some of that water into the ocean, that's bonus. Even more bonus is if you can somehow demonstrate erosion and gradient and maybe load. That would be kind of harder to have in there. What I suggest is sketch it in pencil on scrap paper before putting it on the notes page, right? Where this should end up, where these 5 things should end up, is on the page 2 of the 11.1 notes. But before you draw it there in colored pencil and make it all nice, I would sketch it out on just a random scrap piece of paper. That way you've kind of gotten your ideas down, you've done it in paper, you can make mistakes, erase stuff, change it all around, and once you've got your idea, then you can go and put it officially on the notes page, and you can color it in and make it look nice. So remember, these are the 5 things that we would like to include. The steps of the water cycle, a hill or mountain, maybe a couple of them, tributaries that lead into a river, some kind of aquifer, meaning groundwater storage that is underground, as well as a lake and or ocean.